Hello student, welcome to digital classes. This video is for class 7 science. This video is for class 7 science chapter number 4 heat. This is the second part of chapter number 4. We already discussed about heat in the previous video. That is the part 1 video. We already discussed about heat, hot and cold substance, temperature scales like laboratory thermometer or clinical thermometer. What are the precautions while observing temperature with clinical or laboratory thermometer? The transfer of heat. There is 3 way to transfer heat. One is conduction, convection and radiation. We already discussed about conduction. Now in this video I am going to describe you about convection, radiation and other things in this chapter. We already know about the heat is transferred by convection, conduction and radiation. Convection is the transmission of heat through a fluid like liquid or gas from the hot to the cold region by the circulation movement of the fluid. When liquid and gases are heated, the heat is carried from one part to the another by the actual movement of hot particles. These movement of particles due to the temperature difference between the part of the same substance is called convection. In convection, movement of molecules within a fluid. In reality, this is a combination of diffusion and bulk motion of molecule. Because it occurs at a microscopic level, it is therefore confined to gases and liquid. Molecules in fluids are further apart and have negligible cohesive force. Convection current are set up much faster in gases than in liquids because of the extremely low cohesion force existing between the molecule of the gases. Convection can be natural convection or forced convection. Now I am going to discuss the activity number 6 to show that the liquid transfer heat by convection. Material required: round bottom flask, cold water, potassium permanganate. Procedure: gently place a small crystal of potassium permanganate into a round bottomed flask containing cold water. Heat the water near the crystal with a small Bunsen burner flame. Observe the movement of purple color solution. The purple color solution rises from the place of heating, moves a bit away and then moves down to the bottom of the beaker. Conclusion: this experiment shows that a liquid heat is carried from one part to another by the actual movement of heat particle, that is by convection. Why does the water in the flask move in this fashion? Water near the bottom of the flask get heated first. Warm water is lighter than the surrounding cold water, so it rises up. The cold water from the surrounding move down, gets heated and rise up. This process continues until the entire water attains a uniform temperature. This cyclic movement of the water during heating is called convection current. Air too is not a good conductor of heat. Being a gas, it can flow and spread fast and faster heat by convection. Heat transferred, in which heat is carried from hotter part of a substance to its colder part by the actual movement of hot particles and it is called convection. Only liquid and gases transfer heat by conduction. Solids cannot transfer heat by convection because in solid the constant particles cannot leave their position. Means the particles in the solid are tightly packed. Now the application of convection. Sea and land breeze. Sea breeze, daytime. In the daytime, land heats up faster than the sea. Air above the land expand and rise. Cool air above the sea moves in towards the land. This result in sea breeze. It means during the day the land warms up more than the sea. The air above or over the land become hotter and rise upward. To take its place, the cooler air from the sea move towards the land. This convection current from the sea to land is called sea breeze. Now the land breeze, night time. At sunset, land loses heat faster than the sea water. As a result, the air above the sea or air over the sea is warmer at night. The air over the sea being warmer rise up and to take its place cooler air from the land starts moving toward the sea. The convection current forms the land to sea is called land breeze. Hot water system is based on convection current. In hot water system, boil at bottom, heat up water and cause the hot water to rise. Hot water then move to the hot water storage tank. Cold water from the cold tank then move down to replace the hot water. A convection current is set up. See, I give you one example of ventilation. Ventilation in rooms. Warm air being lighter rise up and leave the room through the ventilators provide near the ceiling. To make up this, fresh air from outside enter the room through the doors and window. The convection current so set in the air help in keeping the air in the room fresh. Air conditioner is the another example of convection current. In air conditioner, cold air blow out by the air conditioner sinks because it is denser than warm air. Warm air rises and is drawn into the air conditioner to be cooled. A convection current is set up. Means cold air is heavier than warm air. The cold air from the air conditioner being heavier move downward, whereas the hot air at the lower level moves up and get cooled and comes down once again. Thus the convection current are set in the air and room get cooler faster. See, one more application of convection current is ocean current. The ocean water near the equator get heated up by the sun rays. As a result, the ocean water in the equatorial region become hotter and lighter. The ocean water in the polar region is cooler and therefore denser. Due to this temperature difference, the warm water start flowing on the surface of ocean from the equatorial region to the polar region, and the cold water start flowing from the polar region to the equatorial region below the surface of the ocean. Such flow of the ocean water from ocean current. Ocean current help in maintaining the ocean temperature. Now some other application of convection current in our daily life are described. Why are air conditioner fitted at a higher level on the wall of the room? Cooler air is heavier than warm air. The cool air from the air conditioner being heavier move downward, whereas the hot air at the lower level move upward and get cooled and come down once again. Thus the convection current are set in the air and the room get cooler faster. Now the second question, why are room heaters placed at or near the floor of the room? The air heated by the room heater goes up and the cooler air from the higher level comes down and gets heated to go up again. Thus the convection current are set in the air and the room gets warmer faster. Third question, why is the freezer mostly located at the top in a refrigerator? The air inside and around the freezer compartment get cool and moves downward, and the less cool air moves up to get cooled. Thus convection current are set in the air and the lower section of the refrigerator also get cools faster. These are the some application of the convection current, and these are some important question. You have to write down these question in your classwork notebook. Now the third mode of transfer of heat is radiation. Radiation is the transfer of thermal energy by electromagnetic waves. Conduction and convection require a medium to transfer thermal energy. However, radiation does not require any medium. It can take place in a vacuum. Direct transfer of heat from hot body to a cold body having no contact between them and without the help of any medium is called radiation. The heat transferred by radiation is called radiant heat or thermal radiation. We feel warm when we sit in the sun, in front of fire or in front of electric heater. How does heat travel from sun, from fire and from electric heater to us? There is no direct contact between us and the source of heat. The air between us and the source of heat is a bad conductor of heat. Therefore, heat transferred cannot due to the conduction. It cannot be by convection because the hot air rises upward and not travel towards us. In fact, heat from any distant source reaches us by the another mode of heat transfer called radiation. The source of thermal energy is radiation transmits energy in the form of waves known as infrared radiation. When absorbed, the energy of the wave transformed into thermal energy of the receiving body. Radiation is the mean by which energy reaches us from the sun. The sun's energy travels to the earth in electromagnetic waves at a speed of light. Now the rate of energy transfer by radiation is affected by the surface temperature, the color and the texture of a subsurface, or the surface area. Radiation heat transfer. All objects emit, absorb or transmit radiation. Heating an object makes it radiate more energy. A dull color surface is a better emitter than a shiny one. Absorption of radiant heat. Radiant heat consists of thermal radiation. When thermal radiation falls on a body, a part of it is absorbed by it. The absorbed radiation makes the molecules to vibrate more vigorously. The increased molecular vibration makes the body hotter. The quantity of heat absorbed by a body depends on its surface or distance from the source of heat. Black bodies are better heat absorber than the white body. Black bodies are better heat radiator than white body. Black body is good absorber as well as radiator. Now, a black body is an ideal emitter. Energy emitted by any real surface is less than what is emitted by a black body. Assumption involved it is a ideal emitter. At every frequency it emits as much energy as or more energy than any other body at the same temperature. It is a diffusion emitter. The energy is radiate isotropically independent of direction. The microchromatic emissions power is defined as the rate per unit area at which the surface emits thermal radiation at a particular wavelength. A black body has the highest emitter or emission power for any given wavelength. Application of radiation. Cooling fins at the back of the refrigerator. It's it is rough and painted in black. Black and rough surface is a good radiator of heat. The motor of the refrigerator can be cooled down quickly by the cooling fins. And the compressor of the refrigerator is also painted with black. Teapot has smooth, shiny, and silvery surface. Smooth, shiny, and silvery surface is a bad radiator of heat. This reduces rate of heat loss. Tea or coffee can be kept warmer in the teapot for longer time. Houses may be painted with white color or bright color. In hot countries, houses are painted in white to reduce absorption of heat energy from the sun. You see the container that is silver colored, which is basically in a nuclear power plant. So they are silver colored, and the fire suit are also silver color to prevent radiation. Silver color is bad radiator. In vacuum flask, a vacuum flask is used to keep hot water hot or keep ice cream or cold things cold. It does this by reducing or stopping convection, conduction and radiation. It is a double walled glass bottle. The space between the two walls is a vacuum. This can stop energy transfer out by conduction and convection. It cannot stop radiation as the radiation can take place in the vacuum. The shiny bright silvering surface on the glass wall reduces heat loss by radiation. Cork stopper, which is made of poor conductor, reduce heat loss by conduction and convection. Now these are the some important question I want to discuss with you. Why is it more comfortable to wear white or light colored cloth in summer and dark colored cloth in the winter? We wear white or light colored cloth during summer but dark colored cloth during winter. This is because white or a light color clothes absorb lesser heat and keep us cool during summer. On the other hand, black or dark colored clothes absorb more heat and keeps us warm during winter. Why does an electric room heater has a polished surface? An electric room heater is provided by a curved polished metal reflector behind the heating element. This polished surface reflects back all the heat radiation falling on it toward the person sitting in the front of the room heater. Why is the bottom of the cooking utensil painted black whereas the sides are sparkling bright? Black bodies are good heat absorber and bright and white bodies are poor heat radiator. The bottom of the cooking utensil is painted black so that it can absorb more heat, and the sides are kept bright so that they do not radiate or lose heat. Why are the pipes of the solar heater and containers of the solar cooker painted black? Pipe black bodies are good absorber of heat. The pipe and the container are painted black so that they can absorb maximum heat from the solar radiation. Finally, a bright shiny surface is a poor absorber of heat radiation because it reflects the radiation falling on it. Radiator in car, buses and refrigerator are painted black. Do you know why? Black bodies are better radiator. A fire fighting suit is bright and shiny so that it does not absorb more heat. Now I think everyone understand about this chapter number 4 clearly.